One of the most challenging aspects of this demolition is the chimneys. So the chimneys are 198 metres tall, but the walls are very thin, only 45 centimetres thick. And that, in technical terms, is described as a thin wall chimney. They're not in very good condition. There's a possibility they would telescope once we detonate. So we've designed, in a fairly unique design, reinforced concrete hinges at the base to ensure that if we do get telescoping, the base will rotate over. So we carried out test blasts, and on the basis of the test blasts, we were able to determine the positioning of holes and the charge weight that we would put down each of the holes. So the heels have been designed with reinforced concrete on the outside, reinforced concrete on the inside, and tied through with heavy rebar, and it essentially triples the thickness of the walls at base level. That will absolutely guarantee that we don't get sit down at that level. So to ensure that the chimneys fell in the right direction, we did a number of things. First of all, we pre-cut 3 windows in each chimney. We also constructed, for the first time ever in the UK, reinforced concrete hinges to make sure we had a fulcrum point for each of the chimneys to rotate about. One of the obstructions we had to remove from the drop zone for the main chimneys was a steel flue. The steel flue was asymmetric, gave us some difficulties, but by engineering, cutting and pulling, we were able to rotate that away and clear it before the main chimney demolition. One of the other concerns with a very large chimney is the expelled air coming out the end of the chimney as it hits the ground. So for that, we built up very high gravel embankments made from recovered materials taken from crushing concrete and masonry on site. Given the symmetry of the chimneys and the symmetry that we've constructed the heels, the chimneys will fall in an easterly direction. The most easterly chimney will go first, and 1 second later, the second chimney will go. Because of the very close proximity of the chimney to the main boiler house, we've introduced a couple of innovations. First of all, rather than just blast out the heel in one, which we would normally do, we've gone for 9 millisecond delays on the bird's mouth to minimize the air overpressure. And we've also gone for a secondary high-level bird's mouth to ensure that we are taking away the front as the chimney comes over. Protection is fairly standard, chain link fencing with geotextile, but because of the 9 millisecond delay, we're expecting it to perform extremely well.
We've got a number of assets, National Grid, Northern Power Grid, that we have to protect, and the local factories, businesses and homes. So we have built hardcore berms. We're using a number of international sea containers, straw bales.
All waste material that arises from the project gets segregated on site, and any hardcore material has been crushed on site and will be used for backfilling. So no hardcore material has left the site.
So I'm delighted to say that after all the planning by our design engineers and our team on site, including construction of the heels, the chimney demolition went ahead perfectly. In particular, the explosive charges worked as designed to remove the bird's mouth at the base of the chimney. The 9 millisecond delay between each of the charges helped reduce the air overpressure. It was inspiring to us to see both of the chimneys falling in a coordinated fashion, each of them 100% online, and the protection measures we installed prevented any debris fly from causing damage to surrounding properties. As in all projects, it's about teamwork. The team at Ferrybridge worked very well together and have produced, at the end of the day, a perfect demolition result for Keltbray.